Michael from ProfessionalOzone.com, and we're going to talk about some of the ways that ozone treatments can be optimized for best performance. Right now we're going to take a look at understanding ppm, or parts per million, as it deals with ozone treatments in an effective way. Now, part of our goal is to talk about the best practices for ozone treatments because there is a lot of misinformation out there. In fact, the ozone surface industry suffers from some bad information, often promoted by overzealous companies wishing to sell their version of an ozone generator. We offer these short review courses to provide accurate and helpful information for typical ozone treatments. Now, one of the things we want to deal with up front is the myth about introducing fresh air during an ozone treatment. Now, you may have heard self-appointed ozone gurus saying that we need to open a window during the ozone treatment so there'll be enough available oxygen, or O2, to produce ozone, which is O3. Now, we feel this is wrong, partly because it's a convoluted concept. It sounds like there's some logic there, but the logic is very faulty. And what we're really trying to accomplish here is we're trying to raise the level of ozone in the room, not dilute it. And there is a difference in there. This has to do with the size of the equipment that you're using, the area that you are treating, along with a few other things. Introducing fresh air into a room will not serve you well. We think this is a mistaken concept. So let's go on to look at the facts. Now, we want to understand some of the ozone facts. When it comes to ozone shock, we believe this starts at about 12 parts per million, which is a fairly heavy treatment. You won't be able to have people and pets in the room during this treatment. And, in a situation where you're using a substantially strong machine, you might reach 18 to 20 parts per million. This is helpful when you're dealing with mold and mildew and strong odors, as well as perhaps even some insects. At these levels, you may enter the room to see a bluish haze. Don't be concerned, this is not uncommon, but it doesn't always show up. So if you see the blue haze, that's a good thing. Now, ozone treatment supplies an abundance of ozone to the treatment area by converting normal oxygen, O2, into ozone, which is O3. Our goal is to radically raise the level of O3 to high saturation levels, also known as ozone shock. The technical term is parts per million, or ppm. We can determine the level of impact by reaching higher ppms, and the faster we do it and the quicker we do it, the better it is. We take note that even low ozone ppm will still work, but we require a lot more time to solve the problem than ozone shock levels. One of the variables you have whenever using an ozone generator is not only the size of the unit, but the time of the application. We believe it's better to do it fast and hard than slow and long. So that will help you perhaps as you consider how best to treat your trouble area. Now, small machines will plateau when it comes to the parts per million, or the saturation level. And so when we're dealing with this area, we know that by raising the levels in measured by parts per million, we are going to have a more powerful treatment. And so here's the issue. Small generators, small ozone generators producing about 5 to 10,000 milligrams per hour will plateau below ozone shock of 12 parts per million. This will still work, but it's like filling a pool with a half-inch hose. Larger generators will peak at a ppm above 12 parts per million, meaning the job is done quicker and more effectively. This would be like filling the same pool with a 4-inch fire hose. And you see on the chart over here that we can have a small, a medium, or a substantial machine, and we'll hit those levels above 12 parts per million and sustain that level for some time. Now, I want you to be aware of something while we're talking about this. When we were talking about introducing fresh air into the room, you have to understand that the ozone doesn't stay ozone for very long. After about 20 minutes, the O3 breaks apart to go back to O2. So O2 is still available in the room as the ozone breaks down. And our goal is to sustain it that way. If you were to turn off the machine, you would find that the ozone levels begin to drop rather immediately. Also, whenever ozone is attaching to something, it is breaking off that third oxygen atom and going back to O2. So we have a constant need for regeneration of the ozone from the available oxygen. We're not so concerned about the available oxygen in the room. We're concerned about the level of O2 or O3, excuse me, in the room. Large generators will peak at ppms above 12 parts per million, so that's the important thing to know. And power equals parts per million. Now, a 5,000 milligram machine, which is a 5-gram machine, that's the volume of ozone that they put out. When it's introduced into the room, we then consider the rooms as we define it by parts per million. As a rule of thumb, you need about 10,000 milligrams for every 1,500 square feet you intend to treat. A 40,000 milligram per hour machine will shock 5,000 to 6,000 square feet in about a 3 to 4 hour period. So when we're talking about ozone generators, more is better. And you'll find a lot of the small machines are out there claiming they can treat 4,000 and 5,000 square foot areas. They can, but because they plateau at a lower level than the shock value, even though they might claim that they can do ozone shock, that's misleading. They're actually plateauing, and it takes them longer to do the job than more substantial machines. Hope this helps you. We have a video that will illustrate this even further now. All right, I'm going to show you an experiment here that is not a perfect illustration, but it's a good way to get a sense of what I'm trying to explain. When we're talking about parts per million, it really is about the concentration, the buildup, or the domination of one item over another. And it would be if we had black marbles and white marbles. If we had a 50-50 split, then we would be fine. Now, it doesn't help to take away the white marbles because we would have more black marbles. What we really need to do is turn more of the white marbles into black marbles to dominate, to have a more profound impact. Now, I've got a glass here, and it's empty, and what I'm going to use this as an example. So this glass represents a room or a building that we may be treating with ozone. And currently all that is in there is air. Now I'm going to use this red drink to illustrate what we would do. As we add ozone to the room, we are trying to get it to where we are dominating and taking over. So we go from a clear to a area that we have now treated for ozone. And of course, we want a strong application here. We want to change the very nature of what is going on there. And as ozone is an active agent that is oxidizing all of this, the more we can introduce into the room, the better it is. Now, we've heard those commentators who say, well, you need to leave a window open, you need to let fresh air into the room, because that gives us more oxygen to supply for the ozone to be made from. Well, that's a mistake, because frankly the ozone is decaying as it's being made. Some more rapidly, they revert back to the O2 because they find their target area, some organic thing they're going to convert. They drop off the third atom of oxygen and they go back to O2. So you're constantly having a lot of ozone that is reverting immediately. Now, if left alone, the ozone is going to revert back in about 20 to 30 minutes. So there is a cycle in there. If we stop the ozone machine, you would see that there would be a decline of the parts per million, or the ppm, would immediately begin going down, not because we introduced any more oxygen into the room, but because the ozone is now decaying and it's going back from O3 to O2. But if you had a meter, you could see that. Now in this illustration, I'm going to bring in this clear liquid, which is water, and I'm going to say, what if we could then improve the quality of our room, improve the ozone in the room by adding in fresh air? Well, if we do that, we dilute it, and you can tell if your screen is clear that we've gone from a red color to a pink color. We diluted the amount, and in a sense the red liquid has dropped in its ppm because we've introduced the water, which represents normal oxygen. So we are diluting it when we bring fresh air in, and it is not helping the cause, even though there may be some argument for this, that yes, more ready oxygen is going to provide more ozone. Yes, that may be true, but in a very convoluted fashion. What we are trying to do is to create a certain amount of constant in this to where we have the product that is heavily ozonated. So the higher that we raise the parts per million, which is the saturation, that means we have more and more of the ozone present in the ppm. So we don't want to dilute the ozone. We want to starve the oxygen and raise the ozone levels. If we don't have a lot of oxygen available in the room in O2 fashion, it does us no harm. If we don't have enough O3 in the room, that does harm us in the sense that we're not hitting ozone shock, and we're not going to have the impact that we really want to. And if we continue adding more and more water to this, we only dilute it more and more to where we can actually render it almost useless. So that's the illustration that I had in mind to kind of give you a real application. We wouldn't say that we can make a freshwater pool any more fresh by adding salt water to it so we could freshen it again. That's this contrarian thought, and while there's some convoluted logic there, it is not good logic, and it just tells you that some of the promoters who are out there giving this kind of information are not well informed, and they're not the kind of place to go for reliability.